Well, to the people online, you're just having to listen to noise until we get this screen going. There it is. All right. We're getting a little faster, but it's taking a while to get there. Got some work for me? Fantastic. Just put it there on the table. That's great. Let's pray, and we're going to work through the practice test on page 224. Father, thank you for this time we have together. I ask your blessing on these students as we practice for the upcoming exam for Chapter 4. Help them to understand things well enough to do well on the test that they'll be taking on Monday. In Jesus' name we pray. Amen. Okay. So let's get this stuff up there and see what's happening. Problem 1B. Write the following in Egyptian numerals. Do you have what Egyptian numerals mean? Back on page 223. Egyptian numerals for, what's the number? 735. Do I have an Egyptian numeral for 700? No. It looks like 500 is 5 of those little squirrels. So I go 7, so I go 1, 2, 3, 4, 5, 6, 7 of them. And then what am I left with? 30. That would be 3 tens. You follow what I'm looking at on page 223? Now you can either copy that stuff down on a piece of paper, or you can just photocopy that page and bring it with you. But you can't open your book while you're taking the test. You have to have this stuff copied down somewhere. So that's 30. And then 5. And 1s are those little marks. 1, 2, 3, 4, 5 of them. So there you go. I just put 735 in the decimal notation into Egyptian notation. Any questions? So what happens when I have an Egyptian number and I want to put it in decimal notation? I look at the same chart on page 223 again. And what does that little scroll mean? It means 100. What's the little heel bone mean? 10. Another one, 10, and then 1. So what would that be? 121. Everybody follow that? This will be easy if you have notes, right? What will happen if you don't have notes? You'll just pick one that looks pretty and see what happens. The mathematical probability of picking the right one, it's not in your favor. Number 3. Now they want me to write it in Babylonian. And what's the number for 363? So let's look back there at that page again. And Babylonian. What do I do for 50? 1, 2, 3, 4, 5 of those little airplanes. So, oh, that's not Babylonian. Oh, 60. They didn't put that one on the page. You know what you need to put on page 223? Is 60. If it's followed by a space. Everybody follow that? Put that in your notes. So you put a little axe head, and that makes 60 of it. So now where do I get the 3? And leave that space in there. And the reason I write a circle there for the space is because they didn't have a 0, but if I don't put it there, my mind doesn't tend to see it. You could just put an underline if you want to, if you don't like putting a 0 in there. Do something to make sure you're leaving an empty space. And then when you look at problem 4a, do you see that space in there? Does everyone see that space on page 224 in 4a? So what does that first little axe head stand for? 60. Then what are these little flying wedges? 10 and 10. And then these little axe heads are 2. So that would be 60, 70, 82. So write yourself a note about what that space means when you're doing Babylonian. Okay? Any questions? We'll keep moving in. 5a. Do the multiplication 23 times 21 using successive duplications. So here's successive duplications. I go 1 times 21, 2 times 21 is 42. Duplication means doubles it. So you have 21, 42. Let me change it to red here. 21, 42. Then what's after 42? 84. What's after 84? 168. What happens when you double 168? 336. You follow that? Successive duplications. So just write yourself a note. When it says do this by successive duplications, you take the second number and start doubling it. Take the number and double it up. Now, how do you find the answer? Okay, we're multiplying by 23. So if I have 16, 8, 4, 2, and 1, what's that add up to? 31. I don't want all of them. That would be 31 times 21. I want 16. If I take 16 and 8, what does that give me? What's 16 plus 8? 24. That's too much. I want 23. So I skip that and go to 4. What's 16 and 4? 20. So I'm still looking for 23. So add 2 more. And what does that give me? 22. Add 1 more and I'm at 23. Everybody follow that? So now which numbers do I add? This one, this one, this one, and this one. And when I add those 4 numbers together, what do I get for an answer? 483. Everybody follow that process? Now I think what's going to happen on the test is they're going to sometimes they'll put part of this information on there and ask you to tell them what goes in next. But you need to know how to do the whole process to make sure it works. Because if they just said, what's 23 times 21, you wouldn't have to do this stuff, would you? You could just say, where's my calculator? I'll take 23 times 21 and get 483 and put the answer down and circle it. And I didn't do successive duplication. So you're going to have to understand the process because they're going to ask you to do part of the process. Then, what's the second thing they want you to do? Mediation and duplation. Well, mediate means divide by 2. What's 23 divided by 2? 11. What about the remainder? Oh, just throw it away. What's 11 divided by 2? 5. What about the remainder? Just throw it away. What's 5 divided by 2? 2. Throw the remainder away. What's 2 divided by 2? 1. Now, how do I find my answer? Okay, isn't this system kind of odd anyway? You keep throwing away remainders. Well, sure enough, let's pick the odd numbers. That's odd, that's odd, that's odd, and that's odd. So what do I add together to find the answer of 483? This one, this one, this one, and this one. That looks like the other list, doesn't it? Except on the test, they won't use the same numbers for both. They'll give you different numbers. Questions on how to do this? Okay. Question 6. Question 6. Write the following in decimal notation. Do all of you know your Roman numerals? Page 223. Copy them down. What's L stand for?
50.
So I put 50 up there. What's X stand for? 10. What's V stand for?
10.
And 1 and 1. So what's that add up to? 67. So now let's do 6b. Any questions about this one? Let's do 6b. So now we have X, which is what? 10. But look at that. We have 10. And then we have what? 50. What happens when you have a smaller one in front of a larger one? You subtract the 10 from the 50, that makes it 40. Got to keep that rule in mind, don't you? Write yourself a note. What's V stand for? 5. And 1 and 1 and 1. So what does that come out to be? 48. Then why did I put 48,000? Because of that line over the top. Whatever the line goes over, you take all of those numbers times 1,000. Watch this. I'm going to change this a little bit. What if this would have said X, L, V, I, and it was over that. The line was over that. What would that be? What's XL? 40 what? 1,000. And then plus what? 8. Everybody follow that? Do you see that little twist on the problem? 40,000 and 8. Any questions? We ready for 7? 7b. What did I do with 7a? Oh, I skipped it. 7b. Write 42 in Roman numerals. How do I say 40? X and L, right? And then what? 2. How do I say 22,000? Here's 10, 22, and then do what? Put a line over the top of it. What would this mean, just for fun? What would that mean? What would this be?
It's 10,012.
10,000. And then this would be 12. So that would be 10,012. You like that? Isn't this stuff fun? Well, what's number 8 say to do? Write the following in expanded notation. Okay. So, what do we have here? Place values. 10 to the 0, 10 to the first, 10 to the second, 10 to the third. So it's 2 times 10 to the third, parentheses, plus 5 times 10 to the second, plus 0 times 10 to the first, plus 7 times 10 to the 0. Everybody follow that? That's expanded notation. What if one of the answers on the multiple choice part was this? Would that be a correct answer?
The other one's not there, yes.
If this is answer B, would that be a correct answer?
If the other one is not present, then yes.
If the other one's not present? And they won't put them both on there for sure. But does everyone understand? Because what's 0 times anything?
0.
It zeroes it out so you don't have to write it. So watch for that when you're taking the test. In fact, when you come down to problem 9 says, 9a, 3 times 10 to the third, 3 times 10 to the third, plus 7 times 10 to the second, plus 10 times, plus 0 times 10 to the first, plus 2 times 10 to the 0. So what is that? 3,700. No tens, put a 0 in there, and 2 ones. Everybody follow the process? What if it would have had written this? What if they would have said 3 times 10 to the second, to the third, I'm sorry, plus 7 times 10 to the second, plus 2 times 10 to the 0. What would you put down here? 3,000. Then what? 700. And then what? 2. And what would that be if you added those together?
3,702.
So you still get 3,702. You follow me? If they leave that out, but don't just take the 3, the 7, and the 2. You see how you might be tempted to go 372 or 3,720? See, look carefully at those exponential numbers. Make sure you're looking carefully at these numbers here to see where the place values are. That's 10. Better make that clear. That's 10 to the 0. They left 10 to the 1 out. Okay, problem 10. Do the following computation in the usual way and in expanded form. Do you see my note for problem 10? What's it say? Skip it. You like that one? Just skip it. And go to 11. You don't have to do it for the homework either. 10's not on the test. So go to 11. What's 3 to the 4th times 3 to the 8th? What would that be? It's going to be 3 to the what? 12. And how did you get that answer? You add those exponents. What's 2 to the 9th divided by 2 to the 3rd? It's going to be 2 to the 6th. Because you do what? When you divide, you subtract those exponents. Write yourself a note. Keep that information handy. Any questions? skip number 12. Why? What did it say? Oh, another expanded notation thing. We're just going to skip those. Let's go to 13. What does 13 say to do? Change 203 in the base, where did it go? 4 to a decimal numeral. Okay, if the base is 4, then this place is 4 to the 0, this is 4 to the first, and this is 4 to the second. Everybody agree? You just label your place values. What's 4 to the 0? 1. What's 4 to the first? 4. What's 4 to the second power? It's not 8? No, it's not 8. That doesn't say 4 times 2. It says 4 to the second power, which is 4 times 4. Now, do you think the guy who wrote the test knows that some people are going to call that an 8? So on the test, that would be 2 times 8 is 16, 17, 18. Will he have 19 as one of the choices? Knowing, have you taken enough of the test already? Will he put 19 down there to mess with people who make that mistake? Yes, he will. So don't make that mistake. This is the 16's place. So I have 2 16s, which is what? No 4s and 3 1s. So I add 32 and 3, and what's the answer? 35. You got it? So now let's do another one. 143 to the base 5. So now what is it? It's 5 to the 0, 5 to the first, and 5 to the second. So what's the 5 to the 0? That's the 1's place. What's 5 to the first? That's the 5's place. What's 5 to the second? 25's. Okay? Whoops, that didn't do any good, did it? 25's. So now what do I have? I have 125. You with me? Plus what? 4 5's. What would 4 5's be? 20. Plus 3 1's. What would that be? So what's 25, 20, and 3 add up to? There you go. What do you think?
Doesn't make any sense to me, but that's all right.
But you mean it doesn't make sense, or you don't know how to do it?
Yes.
Yes to both?
Yes.
Okay. Remember, if this is the base, then that means in the base 5 system, that means 5 is my number. Like, for example, if I said, let's turn over here, if I said 427 in the base 10, that would be 10 to the 0, right? 10 to the 1, and 10 squared. This is the 1's place. This is the 10's place. And this is the 100's place. Were you ever taught that any place in school? So I have, change it to black here, I have 4 hundredths. What would 4 hundredths be? I have, yeah, come on. I have 4 hundredths. What would that be? 400, right? And 2 tens, that would be 20. And 7 ones, and that would be 7. And that adds up to 427. So do you see how now I'm just doing the same thing, except I have 143 in the base 5? So now it's not 10 to the 0, 10 to the 1, 10 squared. It's 5 to the 0, 5 to the 1, and 5 squared. And when it was base 4, it's 4 to the 0, 4 to the first, and 4 squared. Does that help make sense now? I mean, you say, I don't like it. Well, you don't have to like it to do it. So now this one, the base is 2. Let's change to red again. The base is 2, so what do I have? I have 2 to the 0, 2 to the 1, 2 squared, and then the next would be 2 to the what power? 0, 1, 2, 3, and you just keep going. 4, 5, 2. So now, what's 2 to the 1? That's the 1's place. What's 2 to the first? That's the 2's place. What's 2 squared? That's the 4's place. What's 2 to the third? 2 times 2 times 2? That's the 8's place. So I have 1 8, 1 4, no 2's, and 1 1. So what's 8 plus 4 plus 1? In the decimal system, that's 13. Because they want me to change these from binary, from whatever this is. It said here for this problem, 13. Change these to decimal notation. So figure out what the place values are in this notation and then do the math. Because see, if I change this one to decimal notation, I'm going to get the same answer that I started with because it's decimal going to staying in decimal. But it's like when you change it to something else, then you say, okay, now I have to do the place values, figure out what each place value is worth, and then take these digits times those place values and add them up. $13. Okay? Does that help? Let's do something else. Number 14. What's number 14 say? Change the following to decimal notation. So now they want me to change this, and this is in the base 8. So that's 8 to the 0, 8 to the 1, and 8 to the 2. What's 8 squared? What's 8 times 8? 64. Let me see if I can write that a little clearer. 64. 8 to the first is just 8, and 8 to the 0 is 1. Everybody got that down? So, how many 64s do I have? 1 64. How many 8s do I have? How many 8s? 5. What's 5 8s in decimal? 40. And then how many 8s, how many 1s do I have? 2 1s. That would be plus 2. So what's that come out to be? 64 plus 40 plus 2 would be what? 106. Okay? Number 14B, base 16. Do they show you on that page what A and C stand for? Nope. So do you have it in your notes? Base 16 goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And after 9, what's 10 called? A, B, C, D, E, and F. Everybody follow that? Put that down. You're going to need it for the test. So, the base is 16. So this is 16 to the 0. That's just going to be 1s, isn't it? This is 16 to the 1. That's going to be 16s. This is 16 to the second power. What's 16 times 16? Is it? Do you have a calculator there? Is it 256? Okay. So now, watch. How many 256s do I have? What's A stand for? So I have 10 256s. What's 10 256s? 2,560. Everybody agree? And I have two 16s. What would two 16s be? Plus 32. And I have C. What's C stand for? 12. I have 12 ones. So that would be plus 12. And what does that add up to? 2,604. So you could do all this right and make a mistake in your addition and miss it. And the guy who wrote the test knows what kind of mistakes you make, and he'll put that down as one of your choices. He just likes to do that to you. Problem 15. Convert 3,3. This is 3,3 in the base 10. Convert 3,3, 33 to base 5. So if I'm going to put it in base 5, that means I need 5 to the 0, 5 to the 1, and 5 to the second. Do you follow me? What would be the next one if I needed one more box out here? 5 to the third. And here, you'll see why we don't need that. This is the 1's place. This is the 5's place. What's 5 to the second power?
25.
This is the 25's place. So 33, can you see where the next one, 25 times 5 would be what? 125? This would be 125. That's way too big for 33, isn't it? So I don't have any 125s in 33. So I say 25. So I subtract 25. And I'm left with what? Is 8 right? 33 minus 25 is 8. So I have 125. How many 5s in 8? Minus 5. And that leaves me with 3. So I put 1 5. And then what goes out here in the 1's place? 3. Everybody follow that? Do you want to do it the... Is that down here? Nope. Did the book show another way to do it by division? You want to do it that way too? Okay, let's do it that way. 33, let's turn it back to black here. Let's move over here. 33, whoops, that didn't get it. 33 divided by 5. What's 33 divided by 5? 6, right? And what's the remainder? 3. What's 6 divided by 5? 1. And what's the remainder? 1. And what's 1 divided by 5? 0, remainder 1. So what's the answer? You read going up, so it's 1, 1, 3 in the base 5. Is that the same answer we got over there? Yeah, 113 in the base 5. So that's the division method of figuring it out. Now let's do 33 into base 6. Okay, 6 to the 0 is the ones place. This is the 6th place. And this is, what's 6 times 6? That's the 36th place. How many 36s in 33? Can I divide 33 by 36? No. So I put a 0 in here. You follow me? So, how many 6s in 33? 6 times what would almost equal 33? 5. So I put a 5 in here. And 5 6s, I subtract 30. And that leaves me with 3 1s. Let's do this the long division method. 33 divided by 6 is 5, remainder 3. 5 divided by 6 is 0, remainder 5. So the answer is 5, 3 in the base 6. Is that what we got over here? Yeah, 5, 3 in the base 6. Questions? Ready to keep moving? You getting a headache? You'll probably get a headache on the test on Monday too. And the more you go through this practice test, I mean, I know this sounds strange to somebody to think of doing this, but you say, I'm going to take this practice test now in class. I'm going to go home on Friday since class doesn't meet, and I'm going to just look at this test again and work it like I've never seen it before, work the problems again, and then probably Sunday night before you come in to take the test on Monday, I'm going to work through the practice test one more time. I'll go through the same test 3 times to give myself plenty of practice with it before I get here on Monday. Number 16. Why would anyone do that? Well, because it'll help this test is worth a lot of points. It'll help your grade average. Number 16. Convert 39 in the base 10 to binary. Does everyone know that binary means base 2? If you don't, write that down. Binary means base 2. And that's 2 to the 0, 2 to the 1, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. The next one would be 2 to the 6th. And then what? 2 to the 7th. You see how it would just keep going? So what's 2 to the 0? That's 1. What's 2 to the 1st? That's 2. What's 2 to the 2nd? 2 times 2 is what? 4. What's 2 to the 3rd? 2 times 2 times 2? 8. What's 2 to the 4th? 2 times 2 times 2 times 2? 16. What's 2 to the 5th? What's 2 to the 6th? What's 2 to the 7th? Isn't that fun? We could just keep going, except we need to get this stuff done. Okay, now 39. Here's my number, 39. Well, there's no 64s in 39, but there is a 32, right? So I subtract 32. And what's that leave me with? 7, doesn't it? Any 16s in 7? Nope. Any 8s in 7? No. Any 4s in 7? Yes, one of them. Minus 4. That leaves me with 3. Any 2s in 3? Yes, one of them. Minus 2. That leaves me with 1. Any 1s in this? Yes, one of them. And there's the answer. 1, 0, 0, 1, 1, 1 in the base 2. And if you wanted to do it, the long method, you would come out here with, what's the number? 39. And start dividing by 2. What's 39 divided by 2? 19, right? What's 2 times 19? So it's 19 remainder 1. What's 19 divided by 2? 9 remainder 1. What's 9 divided by 2? 4 remainder 1. What's 4 divided by 2? 2 remainder 0. What's 2 divided by 2? 1 remainder 0. What's 1 divided by 2? 0 remainder 1. So what's the answer? 1 0 0 1 1 1 in the base 2. Is that what we got? 1 0 0 1 1 1 in the base 2. Remember, you always read your answer going up. 1 0 0 1 1 1 in the base 2. There's your answer. Pick a method that works for you and you're on your way. Number 16B. 527. Whoa. Well, up here it says binary, so I'm already looking up here at what I have. After 2 to the 7th, I have 2 to the 8th, which would be, what's 128 double times 2? 256. And what's 2 to the 9th? 512. Ah, that's high enough. So now I'm looking for 527. So I take, let me put this down where you can see it. So I take 527 minus 512, and that leaves me with 5 and 1. I guess I should be doing this in red. So 527 minus 512 is 15. So I have, that was 2 to the 9th, so I have one of these. What's 2 to the 8th? 256. None of those. What's 2 to the 7th? 128. None of those. What's 2 to the 6th? 64. I'm looking for 15. None of those. What's 2 to the 5th? 32. None of those. What's 2 to the 4th? 16. Almost, getting close, but none of those. What's 2 to the 3rd? 8. Ah, there's one of those, so I subtract 8. So I put one of those down here. And then what's 2 to the 2nd? 4. What's 15 minus 8? 7. Is that right? Then I subtract 4. So I put one of these in there. And that leaves me with 3. And how do I say 3 in binary? 1, 2, and 1, 1. And if you did that the long way, there it is, right there. 527 divided by 2. You just keep dividing by 2 and working your way down, and you end up with the answer. Same answer that we have here. Okay? Number 17. Convert 47 to base 8. So that's the 1's place, and that's the 8's place. How many 8's in 47? 6 times 8 is 48. That's too much. So 5 times 8 is 40. So I have 5 of these, and I subtract 40. And I'm left with 7. So 7 goes in there. So what about 16s? This is 1s, and this is 16s. So now here's 47. How many 16s in 47? 4 16s is 3 16s is 48. So I want 2 16s. That would be 32. And 5 and 1. Do I put 1 5 in that box? What's 1 5? Where's my little code up here? Where'd we do that? Huh, I don't see it. Well, then we'll just figure it out. 15 after 9 is 10, 11, 12, 13, 14, 15. And this is A, B, C, D, E, F. So I put F in the box. Everybody follow what's going on? Number. Here's the way you would do it, the long division method. Here's the long division method for both of them. And then 15 becomes F. Number 18. Add. 1 and 1 is 2. How do I say 2 in binary? Put down a 0, carry the 1. 1 and 0 is 1. 1 and 1 is 2. 0, carry the 1. 1 and 1 is 2. 0, carry the 1. You got it? How do I subtract in binary? What's 1 minus 1? 0. What's 0 minus 1? You can't do that. I have to borrow here. That becomes 0. And now I have 2 of these. 2 of these minus 1 of these leaves me with what? 1 of these. 0 minus 1, I can't do that. I have to borrow from here, and that gives me 2 of these. 2 of these minus 1 of these leaves me with 1. And there's the answer. You want to check your work? Just add these two. Take these two and add them together. 1 and 0, carry the 1. And 1 and 1 is 3. 1 and 1. There it is. So I got my original number, so I know I did it right. 18, 19. Multiply. Multiply. You take 1 times this whole row and you get 1, 0, 1. Take 0 times this whole row, you get 0, 0, 0, 0. Take 1 times this whole row, you get 0, 1, 1, 0, 1. Draw a line and add. There you go. Got it? I'll be around after class if you need some help. 21. Add 632 in the base 8 and 46 in the base 8. You got your base 8 stuff with you? You got your little chart there that I gave out the other day? There's some of them sitting at the end of the tables if you need one. What's 6 and 2 according to that addition thing? When you add 6, what's 6 plus 2 in your head? 8. How do you say 8 in base 8? 0 and carry the 1, don't you? Is that what the chart says? 6 plus 2 is 1, 0. Then I add 3 and 1 and get 4, and 4 and 4, I get 8 again, and 8 would be 0, carry the 1. And 6 and 1 would be 7. You got it? Multiplication. Look at your chart. What's 5 times 7? What's your chart say for multiplication is 5 times 7? A 3 and carry the 4. Why would that be? 5 times 7 is 35. Yeah, in your head in decimal it is, but how do you say 35 in base 8? 4 8s, 32, plus 3 1s, so 4 3. Then you, so that's 5 times 7. Now you take 5 times 3 and you get what? 15. And how do you say 15 in the base 8? What's 5 plus 3? I mean 5 times, how do you say multiplication? What's 5 times 3? 1 7 in the base 8. Why? Because 15 is 1 8 and 7 ones. So now you take 1 7 and add, what was that, 4? What's 7 plus 4? Is it 1 3? Is that what the chart says? Yes or no? Yes? Because 11 in decimal is 1 8 and 3 ones. So now we have 1 and 1, so the answer is 2 3. So I put 2 3 3 in the base 8. Number 23, subtraction. I can't subtract 6 from 2, so I change this to, instead of 3, what is this? This is 8 to the 0, and 8 to the 1, and 8 squared. So I change this to 2 8s, so now I have 8 over here, plus 2 more. What would that give me? 8 and 2 would give me how much? 10. What's 10 minus 4? I mean 10 minus 6, sorry. What's 10 minus 6? 4. You got it? So then I can't subtract 4 from 2, so I come here and borrow this, and this becomes 5. And now I have 5 64s, and what do I do with the other 64? That becomes 8 8s. So I have 8 here, plus those 2 makes 10 again. 10 minus 4 is 6, and then 5 in front. Skip 24, and that brings us to 25A. And skip 25B. No multiplication in base 16. Just adding these together. What does C stand for? 12. What does D stand for? 13. What's 12 and 13? Is that 25? How do you say 25 in base 16? One 16 and what? 1 9 in the base 16? Is that right? Look at your chart. For basic, what's C plus D?
19.
What?
19.
So I put a 9 down here and carry the 1. What's B plus 1? That'd be C, wouldn't it? What's C plus 5? 11? Put down a 1, carry the 1. What's 2 and 1? 3. So it's 319 into base 16. See the process? You can use your chart, or you can just keep doing math in your head with decimal and translating back and forth. Whatever works best for you. All right, that's the exam. Practice, practice, practice. And if you have any questions, I'll be around for a while to answer them or to help you with homework, or if you just need to talk about how dumb this stuff is, we can do that too.
I missed the last one Monday because we had a family event.
Yeah.
So I'm an online student. So
Yep. So all you do is watch the video. And
is it alright if I turn in the lesson that was due today on Monday? Because
sure,
I'm quite finished
that's
yet?
fine.
Thank
That's
you.
fine.